Hi and welcome to video 3 on this annuity series from topic 1, unit 4 of the general math curriculum. And I'm going to talk to you about establishing the interest earned. In this part, it's a short lesson and these questions do come up from time to time. It's more important that you know how to develop the annuity. This will be an add-on to that type of problem. What I've written down here is a whole bunch of formulas. And I'll explain these formulas. These are the ones that pop up in different textbooks. They're floating about. But I actually think in the long run, if you understand what interest earned means, you will do fine without these formulas. That's my opinion. I'll leave it up to you. So let's talk about the formulas though. First of all, remember D is our deposit amount. N is the number of time periods. We established that earlier. And so the money in is equal to N times D. Earlier I did a 24-month annuity at $300 per month. So 24 times $300 was the money in. And the money made will be the amount I have at the end minus the amount I started with, which is often zero. But sometimes I might start with an investment of $1,000 or something like that. So that's my total money made. And the interest earned will be the amount of money that I have in addition to my starting point, so the money made, minus the amount of money I personally invested. And the difference there will be the interest that I have earned on my investments. So that works out. There's some algebra there if you can play with. Of course, we've got the withdrawal phase as well. And of course, the money out, it's a similar thing. The money I've taken out is N times D. Earlier we did that one where for 45 months I took out $200 and at the end I had $95 extra I could take out. So I might need to just add an extra final payment, AN. And then the money lost is A0, what I started with, minus my final amount left, which may be zero, but it might not be. So if AN is the final payment, I don't need to include it over here. So I've got my money out, the amount of money that I have gained from this investment, and the money lost, how much the investment's changed by it. The interest earned will be the amount of money I've gained minus how the investment's changed, and that will be the amount of money that I've earned in interest, which I now have. Hopefully you can see that's a really logical process. Just think about how much money have I personally put in or personally taken out, and how much has the investment changed in value. And if you equate those two, you're going to get something that represents interest. In my opinion, probably don't memorize these formulas. So let's look at an example of this. Ava invests $1,000 per year at 7% per annum for 10 years. How much interest does Ava earn during this investment? Investigate with the spreadsheet whether Ava would earn more interest if she invested the same amount per year but monthly. So let's calculate our investment as a recursive function. And when I do that, I'm going to set my A0 equals $1,000. And then AN plus 1 will be equal to AN times 1.07, which is 1 plus 7% per annum. It's a nice number this time, plus an additional $1,000. I need to be a bit careful about how I add these up to make sure that I'm not double, triple counting, etc. So when I now do that sum 10 times, I come out with A10 is equal to $15,783.60. But I do have to be careful here because I've obviously added that final $1,000 at the A10 mark. So I'm going to cut that down to $14,783.60, and we'll just assume that that person doesn't go and add $1,000 in on the same day as they withdraw the whole amount or end the savings scheme. So there's our final amount. Okay, we're on a spreadsheet, and it's going to be a pretty rough spreadsheet that I put together here. I'm not going to make it pretty, and we'll have pretty simple titles, but let's build this up. So first of all, we'll have our month number. And then we'll have our investment, or actually no, we'll have our start value, and then we'll have the interest earned on that start value, and then we'll have the investment, and then we'll have an end value, which will be the sum of those. So just to show you how this works, I'll put in 1 into month 1 and 2 into month 2. And if I am clever with that, highlight them both and drag it down. The computer is clever and I'll drag it down till I get to 120 because 10 years is 120 months. So that's good. Now that will help me later on as well. I'm going to start with equals $1,000 but divided by 12. And it keeps my accuracy there, but I'm investing that $1,000 but 12 times over the year. And my interest will be equal to what I start with times by 1 plus, and it will be 7 over 1200. So hopefully you can see what I'm doing there. 7 over 1200 gives me my monthly rate. And that just adds that on. And then I invest a further equals 1000 divided by 12. And my end amount is equal to this one plus this one. And then my start amount is equal to my end amount. I'll just drag that down. And what I'm going to do now is I'm going to highlight those three and use this little black box to drag that down to there. So I've got an even rows, it does the calculations for me, and then I'm going to drag this right down to the end, right down to 120. Okay, and there's my value. Now I have got this additional last payment, but as you can see, I've earned $14,507.87 there. So using the monthly, we get $14,507.87 with no rounding because we use a spreadsheet for that. I'll fix up my 5. Now you can see that she's actually done worse during the monthly situation. And let me explain why that is. On the yearly case, what we've done is we've invested $1,000 at the start of the year. Whereas in the monthly case, we've been investing $83.33 recurring, that goes on forever, each month. $83.33 each month, etc., etc., which means that this $1,000 gets 7% interest for the entire year. This $83 gets 7% interest for the entire year. This $83 only gets 11 months of 7% interest. This $80 only gets 10 months. This one only gets 9 months. So this $1,000 doesn't get treated equally, and this happens every year. Because we're investing the $1,000 at the start of the period, it's actually better to invest it all early so we earn more interest. So it's going to be better off doing this in a yearly fashion. If on the other hand, for some reason we invested at the end of the period, well then the monthly option would be better. But we're investing at the start, so the monthly option's worse because we invest earlier under the yearly scheme, based on, of course, my assumptions. So the questions are, can you construct a table and recurrence relations for an annuity? Can you explain what annuity is? Can you calculate the balance of a deposit and withdrawal annuities at maturity? And can you determine the interest earned on an annuity? And from the textbook we're using, you should be able to do exercise 9A now. All the best.